Good morning, everyone. I hope I'm audible to you.
Yes, sir.
Okay, let us continue the discussion which we have started in the last lecture. We were discussing and try to collect the information about the microprocessor-based system. So here I have shown a microprocessor communicate with the memory and with the output devices, and for which it requires three buses: address bus, data bus, control bus. The address bus is used to identify the location, memory, input or output device to which the microprocessor wants to communicate at that point of time. Then data bus is a bunch of line which carries a data from processor to peripheral device to processor. And the third bus is a control bus. Control bus is used to offer a specific timing for every communication. See, now this processor requires to communicate. Communicate means what? The data or to accept the data. It requires to communicate with a memory. It requires to communicate with input devices to accept the data. It requires to communicate with the output device to transfer the result. So anyhow, the processor requires to communicate memory, input or output. But time required for that communication varies from device to device. It requires some specific microseconds to communicate with memory. It requires some more time to communicate with input devices. It requires some microseconds to communicate with the output device. So when the processor communicates with input, memory, output devices, it requires to offer a sufficient time for communication. And within that time, the communication should happen completely. So that time is offered by this particular bus. Of course, the timing is measured in terms of microseconds. So the frequency is in a megahertz, 1 upon mega is called micro, so microseconds, but maybe some microseconds are required for input, may not be the same microseconds required for communication with the memory. Before I move towards the next one, let me tell you one thing. You might have purchased the USBs. USB pen drive. So you may find sometime if we are going to purchase a 8 GB pen drive, the price varies. That price depends upon the speed of that pen drive. The pen drive which is having a faster speed of communication will definitely cost more. Storage will be same, and the pen drive or USB drive, which may be the communication speed is less, will cost less. So every peripheral device requires some speed. This is just an example given. I mean to say that a control bus is a bus which offers a specific timing for communication with the peripheral devices. So this is the first point. Provide specific. So it provides a specific time for communication with the memory input and output. I will write generalize with the peripheral devices. With
So your screen is not visible.
yes,
Your screen is not visible. Yes, now it is visible.
Yeah. So shall I go ahead?
Yes, sir.
Yeah.
Yes, sir.
So it offers a specific time for peripheral devices. Okay. Secondly, it is actually a bunch of lines. The way we have explained, address bus is a bunch of lines. Data bus is a bunch of lines. This is also a bunch of lines, but at the end, the decoders are connected in such a way that till it reaches to a peripheral device, maybe memory or maybe input or maybe output device, it becomes a single line. Single line to enable the place from memory, to enable the place from input device, or enable the place from the output device. And it categorized into two different operations. Okay, let me first write the operations, and I'm going to explain which operations are carried out by control bus. So, first one is known as read operation, and the other one is known as write operation. Now, these two specific tasks are to be executed by the control bus. Okay, before I move ahead again, I must give you some example, and that may help us to understand the concept of control bus. See, we are talking about the processor. Instead of that, let us talk about the professor. I'm a professor, suppose, and I want to read something. So what I will do? Obviously, I will collect a book. This is the book, and I open. Something is there. This is a peripheral device. The contents are there in a book. So I open the book and start reading the contents. Okay, this is perhaps a BW book. Fine. So I open the book and start reading the content. And as I go on reading the contents, the data from this book will go to my brain and then it manipulates, and I try to find out the gist out of it. What is the meaning of that sentence or the page or the gist of entire book? So what I did, the data was present in a book, contents were present in the book, and I opened the book and try to collect the data from book, and somewhere here I want to process it in my brain. Then I understand the meaning or the fundamentals which have been given in that book. This is what simple. A professor is trying to read a book. Data from the book to my brain, this process is called as read process. Similarly, here, input device, through input device we can type some data, 10, 20, 30, 40. This data will go to this processor. For what? For computation process, arithmetic and logical operations. So when the data is transferred from input device and the transfer data flow is towards processor, this process is called as read process. Reading the content from input device by the processor. Similarly, one more example. Now there is some thought in my mind, or more specifically in my brain, I can say. And I want to pen down those thoughts. I want to pen down those contents on a paper. What I will do? Now I pick up a notebook. So this is a notebook. Again for BW, fine. Of course, the pages are blank. So whatever thought is in my mind, I'm going to write down or pen down the contents in notebook. So the data was there in my brain, and I just want to pen down, writing on notebook. This process, a flow of data from a professor's brain to a notebook, this process is called as writing. On a similar line, suppose a data is present here. Data may be 10, 20, 30, whatever it may be. Data, simple, 8-bit data. Now this data we are transferring to the output device. A flow of data is from processor to the output device. This process is called as write process. So the way I read the content Here in the processor, data will flow from input device to processor. The way I write, pen down the contents, similarly, data will flow from processor to the output device. So with respect to input device, we can go for only one operation. That operation is called as read operation. Read a data from input device by the processor. And with respect to output device, only we can go for the write operation. Data should flow from processor to output device. Of course, this is the data bus. It has to carry a data, either this way or that way. But then, if the flow is towards processor, it is a read process. If the flow is towards write processor, peripheral device, it's write processor operation. With memory, both the things are possible. From memory, we can read the content, or the contents can be write to the memory. See, I have explained 4 different operations. Let me write down one by one. So reading process. So first of all, it is IO read. IO read means data should flow from input device to the processor. IO is input output device. Perhaps with the output device, we can't be able to read the content. Second reading process is with respect to memory. This is called as memory read process. Write process. With respect to output, this is known as IO write process. With respect to memory, it is called as memory write process. Okay. In a short, with respect to input device, you can go for reading process. With respect to memory, we require for reading process. With reference to output device, you can go for writing process. For memory, you can go for writing process. And for every process to happen, a single line must be enabled. If the line is high, nothing will happen. If the line one असेल ना logical one असेल म्हणजे high आहे त्या मोमेंटला reading writing is not possible. But when the line goes low, ही line जेव्हा शून्य बनते goes low, that time either of this operation will carry out. So these lines are called as active low lines, and a signal has been named. I require 4 lines, no? 1, 2, 3, and 4. 4 lines are there. The name of the way we define the name for every line in an address bus, data bus. Similarly, I must give the names. The name of this line, एक like wire है. Now, this is known as IOR, input output read. After IOR high है ना, nothing is happen. When it goes low, reading process begins. Memory read. This is known as MEMR, memory read. Am I audible to you?
Yes, sir.
Yes, sir.
Sorry, there is some network issue. So, memory read means MEM for memory read, but if it is high, no reading will happen. It must go low. So it should be known as MR bar. So that is memory read. One more signal, IO write. So this is known as IOW. When the signal goes low, हा signal जेव्हा शून्य होईल, low जाईल, तेव्हाच writing सुरू होईल. Known as IOW. And memory write signal is given as MEMW. But when the signal is high, no writing will carry out. But if the signal goes low, that time go for writing. So in such a way that now we have four different signals. These two are to be connected to the memory. MEM R bar is the signal. MEM W bar is the signal. Two signals are joined to memory. One for reading operation, one for writing operation. IOR bar, this is a single signal which is joined to input device for reading process. And IOW bar, this is a unique signal which is connected to output device. So this is the signal. When the signal goes low, we can write something in the output device, maybe printer, plotter, or whatever. So this is about the control bus. So please go through it. You might have taken these contents, and if you have any doubt, please ask me. Meanwhile, I'll go for the next topic. Okay. Topic number 2, please write down. Generic block diagram of microcontroller. Just now we have seen microprocessor. Now we will see microcontroller. Okay, draw it quickly. This is microcontroller. Okay, let us begin the discussion now. I think now we have collected sufficient information, not knowledge, information about the microprocessor. And now we can able to, sufficient means sufficient information about the microprocessor before we move towards microcontroller. Now this is a generic block diagram of microcontroller. Now, according to the manufacturers and specifications and versions of all these processors and controllers, the capacity of memory, capacity of input devices, output devices, peripheral interfacing devices, and the features will go on adding. But what is, probably programmable blocks which are present in a microcontroller should be known to us. But before that, let me tell you what is called as processor, what is called as controller. Processor is a single chip, maybe 40 pin IC, 28 pin IC, and so on. This is a chip, and it will perform the mathematical and logical operations the way we have said. But then, to carry out the task, it requires to communicate with the memory outside peripheral devices, outside output devices, input-output devices. And then a system becomes a microprocessor-based system. So on a PCB, suppose this is a PCB, I will mount the processor and then memory and input device. And this is a PCB. This system is known as microprocessor based system. And normally we go for a bigger operation. When we have to go for handling a large memory size, we have to handle a number of input devices. We have to handle any number of output devices, and the process and program is rigorous and bigger one. That time probably will go for a microprocessor based system. And the best example is your laptops and desktops developed by Intel. But this is not the case always. Sometimes I may go for a small application. If I want to change the lighting or illumination in my lab or classroom, I will not go for computer-based system. I will go for a small dedicated system in which some of the peripheral devices are need to operate. I may require a small program. I will go for a small memory. I will have to use a smaller keyboard having 1, 2, 3, 4 buttons, not like multimedia keyboard. So task will be same. I have to perform mathematical or logical operations, but with a curtailed version, like a washing machine. In a washing machine, some specific tasks are there. I don't require to operate the washing machine with the help of computer. Ignition of bike ignition, DTSI. Suppose Pulsar is there. It's a digital twin ignition system. It has double sparks double in a single cycle of IC engine. Fine. I want to adjust the firing of that spark plug. I will not go for a computerized system. I will go for a microcontroller based system, small applications. So whenever we go for dedicated application, somewhat smaller than the operations which are handled by the processor, we will go for a device which is known as a microcontroller. But then, if I am going for a microcontroller, my wish is to get a ready-made IC. This IC must consist everything. I don't have to connect them separately. That is why I'm going for a dedicated system. So this microcontroller chip, which is behaving or performing same as a processor, but then a single chip must have all that components which I require to mount on a PCB. This IC must have memory, small memory, but fine, that should be there inside. I will not connect separately. Peripheral devices, I will change the word now, not peripheral devices, interfacing device, I'll tell you. So interfacing device where I can connect the input devices, output devices, that should not be separate, that should be included in this IC. So I require small memory that should be inbuilt inside. Interfacing devices should be inbuilt inside. And some typical applications. I will go for ADC conversion. Maybe a real-time signals are analog and a processor or controller works on a digital signal 1010. So I require to convert analog to digital. That I don't require to connect separately. That feature should also incorporate in a IC, in that IC called as microcontroller. So I need to say that this is one IC. This is not a board. A board nahi hai. This is IC. This IC consists of microprocessor. MP is there. What MP consists of? It consists of arithmetic and logical unit. We have seen in the first lecture. It consists of number of registers. It consists of control unit. Along with that, a single IC must consist of memory, even the smaller one, memory, input, interfacing devices. I will tell you the difference between interfacing device and peripheral device. It must be having output, interfacing device. It must incorporate the feature of ADC. Fine. Sometimes I want to go for a serial communication. So the processor handles a data in a parallel. Parallel means 8 bit multiplied by 8 bit, 16 bit multiplied by 16 bit, addition of 8 bit with 8 bit. So we handle a data parallelly. But when we go for longer communication, one of the server is here and the other end is at far. We will not go for parallel communication. We go for a serial communication. Telephone line is the best example. Internet line is the best example of that. Broadband. It's a serial communication. So, I may require to convert a data which is parallel to serial, or even sometime I require to convert a data from serial to parallel. To my laptop, if I have joined the internet line will carry a serial data, and this laptop requires a parallel data. In between that, I require serial to parallel converter. Now, if my laptop is as a server, I want to send some data to peripheral computer. The data handled by laptop is parallel, and that is also a parallel data. But for transmission, I will go for serial communication. So I require serial communication. Serial communication module must be there. In a controller, normally we go for counting process. I want to count the events, number of students entering into the class, number of students leaving from the class, how many have attended the process. I want to count 1, 2, 3. So this IC must have that feature also. That is known as counter. Sometimes I require the feature of offering a delay. I want to turn on the light, but light should not turn on immediately the moment I press the button. I press the button, after 5 minutes, light should glow. I require a time delay. I want to execute the process after some delay. So obviously I require a timer. Timer must be there. Now my processor is handling mathematical and logical operations fine. At the same time, I want to run the media player also. I want to run the different applications. So at the back end, different applications will run, and at front end, my main program will execute one by one, line by line, statement by statement. So processor will handle one task at one time, fine. But sometimes we go for a parallel execution. Example, okay? On your laptop or on a desktop, you are writing something in an Excel sheet or in a Word. At the same time, a media player will run song for you. Secondly, when you are going for, of course, you are using MATLAB or you are writing a program in a MATLAB. At the same time, in a different window, you have kept one folder to copy from drive to pen drive to drive. That process is going on at back end side, and at front end side you are doing a MATLAB programming. I mean to say that if I want to copy the content from one memory to second memory, hard disk to pen drive to hard disk, my wish is to copy the content and paste it to other location as fast as possible. as fast as possible. With normal processing execution or program, it happens, it requires almost double the time. To reduce the time straight away to half, we require one more device. That's an AVA, direct memory access. This is used to expedite the process of transferring the content from one location to other location. That is also there. Maximum we try to incorporate the feature in a single IC. That IC is called as microcontroller. I mean, whenever we use a question in a oral, and this is the typical question and typical answer given by students. I used to ask the students, what is microprocessor? So it processes the function. Okay. And what is microcontroller? Sir, it controls the function. What is the meaning between that? Anyhow, the processor has to control the process also. So it's not like a controller has a different feature controlling. No. The thing is like in a controller, we try to incorporate, or rather, not we, the manufacturer, they try to incorporate all the features for a small dedicated application, and that is incorporated in a single IC. So that IC is called as microcontroller. Perhaps both are working with almost similar speed, and both are carrying out almost similar kind of activities. Everything is same, but then the add-on features if we have obtained in a single IC, that IC is called as microcontroller. So this is not a board. A board नहीं है. है एक single IC. Maybe developed by Motorola, maybe developed by Siemens, maybe Siemens, or maybe developed by Intel. This is a single IC. Please write down this quickly. Let me note down some points. Direct. Your voice is breaking.
Yes, sir. DMA stands for
Direct memory access.
okay, sir.
As we move ahead now, we will put some more stress on that DMA. आता ना, आता just block पुरतं meaning आहे direct memory access. I think chapter number 3-4 मध्ये तुम्हाला एक लागेल. DMA काय आहे, तो काय करतो. म्हणून म्हटलं, it's like a tree. At once, I will tell you everything, not in detail. Next lecture, I will explore the points, some more points, something more, something more. In that, we will go ahead. But then, this is a microprocessor and input and all the other devices in a single IC. It requires 3 buses: address bus, data bus, control bus. But I will not draw all the lines. I will just draw a bunch, including everything. It consists of address bus, it consists of data bus, it consists of control bus, just to avoid the complexity in this block diagram. So let me draw a bus. It consists of address bus, data bus, control bus. And then the appropriate address bus, data bus, and control buses are connected. Along with this, when we obtain everything in a single IC, that IC is called as microcontroller. This is the generalized block diagram of microcontroller. As we move ahead in our syllabus in detail, we will go for a specific. How much will be the memory? What is the size of input devices? What is the specifications of ADC, DMA, serial communication? That we see in our. Okay. Just a minute. Huh? Before I move ahead, let me ask you, समझते is it little bit little bit fast? समझते क्या? समझत?
Yes,
हाँ
sir.
समझते.
Yes, sir.
काय होतं कधी कधी फास्ट होतं एक्सप्लेन बोलता बोलता मला वाटलं काही कळत नसेल तर प्लीज स्टॉप मी अँड विल एक्सप्लेन विथ द प्रॉपर पेस. The first block is ALU. The ALU, you have information. Let me write the information quickly. Now, this is the block where we carry out the mathematical and logical operations. So, ALU, here we carry out arithmetic operations like addition, subtraction, multiplication, and division. Division of two 8 bits, addition of two 8 bits, multiplication, division. This is possible here only. Apart from this, it will perform the logical operations like logically OR and XOR, inversion, and so on. So logical OR and NOT, etc. So this is a place. At a time, we can perform the addition, subtraction, multiplication, division, and or XOR NOT with only two data contents. The data may be in terms of byte or data may be in terms of word, 16-bit or 8-bit. But the device which is for our syllabus will carry a data which is of 8-bit, 8-bit addition, 8-bit multiplication, 8-bit division, and so on. So this is called as an 8-bit processor or controller. This is 8-bit controller. What I meant to say, yes. Now this is, if you ask me what is it, how it looks, yes, it looks like this. Don't draw it. It is a register. 1, 2, 4. So this is a 8-bit register. हा काय आहे? हा एक register आहे. यात आहे 8 flip-flop. And every flip-flop will carry 1, 0, 1, 0, what it may be. So this is a simple 8-bit register. In the first lecture said, register is a combination of flip-flops joined together. So this is an 8-bit register. So that is called as ALU. The same is called as register A. The same is called as accumulator. The same is called as W register. आपण नाही का there is a person. He may be engineer, he may be a teacher, he or she may be scientist, researcher from medical field. So depends upon the profession carried out by that fellow. We used to call that as the different names. Of course, and that fellow has his own name. So depends upon situation, we used to call it. Similarly, this 8-bit register depends upon the function. It may be called by different names. May be called as a ALU, may be called as a register A, accumulator, or W register. We see it one by one. In this register, which looks like this, when I carry out the mathematical or logical operation, that register is called as ALU. Mathematical or logical operations जेव्हा मी परफॉर्म करतो त्या रजिस्टर मध्ये यामध्ये त्याला मी काय म्हणतो I used to call that as a ALU. When this register is used not for any mathematical or logical operation, this is used merely to store some data. काही वेळापुरता एक डेटा सेव्ह करून ठेव फॉर टेम्पररी पर्पज. कुठलंही ऑपरेशन नाही, मॅथमॅटिकल लॉजिकल काही करायचं नाहीये. त्यावेळेला द सेम विल बी कॉल्ड ॲज रेजिस्टर ए. दिस कॉल्ड ॲज register A when we go for temporary storage of a data. Data किती असेल 8 bit. हा आहे 8 bit. So I can't able to store a data more than 8 bit. So this is called as register A. आता बघा. Now this same register will be called as accumulator. कधी बघा? Simple. Here. 10 अधिक 20 is equal to 30. Now this is my program. Data, instruction. I have written a program. So for this purpose, I must write a program. At the end of program, I will be getting a result. आता result कुठे आहे बरं? हा result आहे यामध्ये. याचं नाव आहे accumulator. So where the same device or register is used to store a data, but that data is not a typical data, that is a result. That time, the same place is called as accumulator. It accumulates the result, right? To store the result. Not for the entire time, no, just for temporary purpose, because immediately there will be a next operation. Immediately there will be a next storage of result. The place is called as accumulator. And this is also called as W register. W म्हणजे काय? Working register. Working register. आता हे कधी बरं? Normally, the devices which are developed by Intel, they used to call only ALU, register A, or accumulator. But now the device is developed, this controller is developed by Microchip Corporation. They said that I will offer the different name. So the same place, same register used by Microchip and not by the Intel. That time, that is called as working register. What is the function of that working register? Say, to perform these operations, and to store the result. But then used by Microchip Corporation. So that is called as working register. So this is for PIC microcontroller. PIC म्हणजे काय? Peripheral Interfacing Controller, microcontroller, developed by Microchip Corporation. So this is the information about ALU. Just लिहून घ्या. Now we'll go ahead. Just we have seen one block. I think we have time or not. ठीक है. We'll continue the discussion in the next lecture. Out of this entire, we have just seen ALU in more detail, which is perhaps not explained in the last lecture. Slowly we'll go on explaining all the other blocks in this microcontroller. Wait a minute. Let me collect the attendance. जर काही शंका असेल तर विचारा, अदरवाईज यू कॅन लीव द क्लास.